Welcome to doassignment-ca. Here is the problem. A uniform rod AB has a mass of 40 kilograms. The rod is 3 meters long and is positioned at 60 degrees from the horizontal. End A slides along a smooth vertical wall using a smooth collar, and end B rests on a smooth horizontal floor with a cable attached at B running horizontally to the base of the wall at C. Determine the tension in cable BC. Now let us work through the solution step by step. Let's start by drawing the free body diagram. The rod has a smooth collar at A on a vertical wall, so the wall can only push horizontally. That reaction is called N sub A, pointing in the positive x direction. At B on the smooth floor, there is a vertical normal force N sub B pointing upward, and the cable pulls B horizontally toward the wall with tension T in the negative x direction. The rod's weight equals 40 times 9.81, which is 392.4 newtons, acting downward at the midpoint of AB. Place the origin at point B. The rod rises at 60 degrees from horizontal. Point A is located 1.5 meters to the left and 2.598 meters above B. The center of gravity G is at the midpoint of the rod, which is 0.75 meters to the left and 1.299 meters above B. Writing the three equilibrium equations, the sum of forces in x gives N sub A minus T equals 0, so N sub A equals T. The sum of forces in y gives N sub B equals W, which is 392.4 newtons. The third equation is the sum of moments about B, which we will use next to solve for T. Taking moments about B is the key step. Both N sub B and T act at point B, so they produce no moment there. The reaction N sub A at A creates a counterclockwise moment equal to N sub A times the height of A, which is 2.598 meters. The weight at the midpoint G creates a clockwise moment equal to 392.4 times 0.75 meters, giving 294.3 newton meters. Setting the net moment to 0 gives the equation N sub A times 2.598 minus 392.4 times 0.75 equals 0. Solving N sub A equals 294.3 divided by 2.598, which gives 113.3 newtons. Since N sub A equals T, the cable tension is 113.3 newtons. We verify by summing moments about A. The weight contributes 294.3 newton meters counterclockwise. The floor normal N sub B contributes 588.6 newton meters clockwise, and the tension T contributes 294.4 newton meters clockwise. These sum to approximately 0, confirming the answer. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.